of the day. I am Mohini Rasar, working as an assistant professor at All India Sri Shivaji Memorial Society's College of Hotel Management and Catering Technology, Pune. I will be introducing you to this session of Physics Under the Bridge course. The topic for this session is the measurements of temperature. Let's take a look at the objectives of the session. Students will understand the concept of temperature, its role in the physical world, and its measurement units. We will explore various temperature scales such as Celsius, Fahrenheit, and Kelvin, and understand their origin. We will also learn about various temperature measurement devices. Practical application of this session will help you recognize the importance of temperature measurement in everyday life, including weather forecasting, cooking, healthcare, and industrial process. We will also learn to differentiate between accuracy and precision in temperature measurement, identify the factors affecting them, and understand their significance in various contexts. Welcome to an exploration of temperature measurement, where we uncover the secrets of this fundamental aspect of our universe. Let's take a look at the science behind temperature and its applications. Let's kick off our journey by understanding what temperature truly is. Temperature is the measure of hotness or coldness of an object or environment. It's what makes your morning coffee warm and your ice cream cold. To measure temperature, we use various instruments which we know as thermometers. These devices work by expanding or contracting in response to change in temperature, providing us with valuable numerical data. Now, let's take a look at various types of thermometers. First type is mercury thermometer. Mercury thermometer uses a column of mercury to measure temperature. The mercury expands or contracts as temperature changes. Reading is taken by observing the level of mercury in a calibrated tube. For example, doctors often use these to check our body temperature. Our second type is digital thermometer, which uses electronic sensors to measure temperature. It displays temperature reading digitally on a screen. It is often a faster and more accurate than traditional mercury thermometer. A next type of thermometer is infrared thermometer. Measures temperature without touching the object. It uses infrared radiation emitted by the object to determine its temperature. It often is used for quick readings or in the situation where contact is not feasible. For example, this temperature thermometers were used or are used at airports and during COVID-19 situation. Our next thermometer is known as thermocouple thermometer. It works on the basis of the principle of thermoelectric effect. It uses junctions of different metals to measure temperature. It produces a voltage that corresponds to the temperature being measured. It is used in places like factories to measure really high temperatures. It is also used to make sure machines do not get too hot. Next thermometer is thermistor thermometer. Uses a thermistor. It is a type of a resistor whose resistance changes with temperature. It measures the resistance change to determine temperature. It is often used in electronic devices for temperature sensing. This one is generally inside things like your phone or car to check if it is getting too hot. Our next thermometer is bimetallic strip thermometer. It consists of two different metals bonded together. When heated, the metals expand at different rates, causing the strip to bend. The degree of bending indicates the temperature. They are used in thermostats to control heaters and air conditioners. Next thermometer is liquid crystal thermometer, which uses liquid crystals that change color with temperature. The color change corresponds to different temperature ranges, often used in a disposable temperature strips or for quick temperature checks. The examples include as follows. Forehead thermometers. Liquid crystal thermometers are often used as forehead thermometers for quick temperature checks, especially in healthcare settings. They are convenient for checking for fever in infants, children, and adults. Aquarium thermometers. Liquid crystal thermometers again are commonly used in aquariums to monitor the temperature of the water. They are usually attached to the outside of the aquarium glass and provide an easy to read display of the water temperature, ensuring that it stays within the appropriate range for the fish and other aquatic organisms. Fermentation temperature control. Liquid crystal thermometers are utilized in home brewing and wine making to monitor the temperature during fermentation. Now, let's explore the fascinating world of temperature scales. We have the Celsius scale devised by under Celsius, where water freezes at 0 degrees Celsius and boils at 100 degrees Celsius under standard atmospheric pressure. Let's understand what is standard atmospheric pressure. Standard atmospheric pressure is the pressure exerted by the weight of the atmosphere at the sea level under standard conditions. It is typically defined as 1013.25 hectopascals, which is equivalent to 1013.25 millibars or 29.92 inches of mercury. This standard pressure serves as a reference point for various atmospheric and scientific measurements. Moving ahead, we have Fahrenheit scale, which was introduced by Gabriel Fahrenheit, commonly used in United States. Here, water freezes at 32 degree Fahrenheit and boils at 212 degree Fahrenheit. Finally, we have the Kelvin scale, named after Lord Kelvin, used primarily in scientific context. It starts from absolute zero, the coldest possible temperature, where all molecular motion stops. Now, let's understand conversion of measurements. Understanding temperatures can be as simple as converting between different scales. Let's learn how. Say we have a temperature of 20 degrees Celsius. Ever wondered what that would be in Fahrenheit? To convert Celsius into Fahrenheit, we multiply the Celsius temperature by a fraction of 9 upon 5, then add 32. Let's look at the mathematical expression. We start with 20, multiply by 9 upon 5, that gives us 36, and then add 32, which gives us the total of 68. So in the context of converting Celsius to Fahrenheit, the fraction 9 upon 5 represents the ratio of the size of 1 degree of Fahrenheit scale to 1 degree on the Celsius scale. Specifically, it denotes that 1 degree Celsius is equivalent to 9.5 or 1.8 degrees Fahrenheit. This ratio accounts for the difference in the size of the temperature intervals between the two scales. So when we are converting Celsius to Fahrenheit, we multiply the Celsius temperature, here in this case 20 degrees Celsius, by 9.5 to scale it appropriately to the Fahrenheit scale. So 20 degrees Celsius is equal to 68 degrees Fahrenheit. Easy, right? Now let's go the other way and understand the conversion of Fahrenheit to Celsius. So if we have 77 degrees Fahrenheit, what would it be in Celsius? To convert Fahrenheit to Celsius, we subtract 32 from the Fahrenheit temperature and then multiply by the fraction 5 upon 9. Let's understand how is it done. In the context of converting temperatures between Fahrenheit and Celsius scales, the number 32 represents the freezing point of water in Fahrenheit. When converting from Fahrenheit to Celsius, subtracting 32 adjusts the temperature to align with the Celsius scale, which has its 0 point set at freezing point of water. This adjustment ensures that both the scales have their respective freezing points aligned. Conversely, when converting from Celsius to Fahrenheit, adding 32 accounts to the difference in the 0 points of the two scales, ensuring that the converted temperature reflects the correct value on the Fahrenheit scale. And hence the answer is 25 degrees Celsius. It is this simple to convert Celsius and Fahrenheit. Last one. But what about Kelvin now? It's a bit different. So to convert Celsius to Kelvin, we simply add 273.15 to the Celsius temperature. In the context of converting temperature from Kelvin to Celsius, the number 273.15 represents the difference between Kelvin and Celsius scales. Specifically, the Kelvin scale 0 point and the Celsius scale 0 point. The Kelvin scale starts at absolute zero, where molecular motion ceases or stops entirely. To align the Kelvin scale with the Celsius scale, 273.15 is added to the Celsius temperature. This adjustment ensures that both the scales have their respective 0 point aligned. So when converting from Kelvin to Celsius, subtracting 273.15 adjusts the temperatures to align the Celsius scale. This adjustment allows us to express temperature in degrees Celsius relative to its 0 point, which is the freezing point of water. So 25 degrees Celsius is 298.15 Kelvin. Kelvin starts from absolute zero, where there is no molecular moment. Finally, we have to go back to Kelvin to Celsius. So we just subtract 273.15 from the Kelvin temperature. Moving ahead, converting the temperatures is as easy as a pie. Whether you're cooking, doing your science experiments, or traveling, knowing how to convert Celsius, Fahrenheit, and Kelvin can be super handy. Now let's see how temperature measurements impact our lives. In weather forecasting, meteorologists rely or depend on temperature data to predict weather pattern accurately, helping us to plan our outdoor activities. Temperature measurement is also crucial in the culinary world. Chefs use thermometers to ensure meats like pork and beef are cooked to perfection. It is done to prevent any foodborne illnesses, and it guarantees a safe and a delightful dining experience. In healthcare, temperature measurement plays a vital role in diagnosing illness and monitoring patients' health. A slight change in the body temperature can signal the presence of an infection or fever. However, accuracy and precision are paramount in temperature measurement. Accuracy refers how close a measurement is to the true value, while precision is about getting consistent results. True value in the context of measurement refers to the actual or real value of the quantity being measured without any errors or uncertainty. It represents the precise value that would be obtained if measurements could be made with perfect accuracy and under ideal conditions. Factors such as instrument calibration, environmental conditions, and human error can affect the accuracy and precision of temperature measurements, highlighting the importance of meticulous calibration and standardization. Before we conclude the session, let's do a quick recap. We studied temperature is essential to understand the physical world. We use thermometers to measure temperatures, and we studied about different thermometers like mercury thermometer, liquid crystal thermometer, and many more. We also studied about various scales like Celsius, Fahrenheit, and Kelvin, different temperature measurement tools including infrared thermometer, and we also studied about how temperature measurements have practical applications in weather forecasting, cooking, and healthcare. As we conclude our journey to the world of temperature measurements, remember, temperature isn't just a number, it is a window into the intricate workings of our universe. Stay curious, stay vigilant, and keep measuring. Thank you.